of reagent. Can you recall what is meant by reagent? Identify the reagent, substrate, products and byproduct in the following. CH3C double bond O Cl react with ammonia. Give CH3C double bond O NH2. Give hydrochloric acid as a byproduct. The polar organic reactions are brought about by two types of reagent, depending upon their ability to accept or donate electron from or to the substrate. Reagents are classified as electrophiles E plus and nucleophile Nu. Electrophiles meaning electron-loving species accept electron from the substrate. Thus, electrophile are electron-seeking species. This is because they themselves are electron deficient. For example, a positively charged ion such as bromine plus CS3 or a neutral species have a vacant orbital such as aluminium trichloride. Nucleophile, nucleus-seeking species, give away electron to the substrate. This is because nucleophiles are electron-rich species. For example, negatively charged species such as OH- or neutral species such as H2O have a lone pair of electrons. Identify the nucleophile and electrophile from ammonia and CS3+. Also indicate the nucleophilic and electrophilic center in them. Justify the structural formula of two reagents showing all the valence electrons are NH3 and HCH3+. Thus, ammonia contains nitrogen with a lone pair of electrons, which can be given away to another species. Therefore, ammonia is a nucleophile and nitrogen in it is the nucleophilic center. CH3 plus is a positively charged electron deficient species having a vacant orbital on the carbon. It is an electrophile. The carbon in it is the electrophilic center. A polyatomic electrophile has an electron deficient atom in it called the electrophilic center, while a polyatomic nucleophile has an electron-rich atom in it is called nucleophilic center. For example, the electrophilic center of the electrophile aluminium trichloride is aluminium, which has only 6 valence electrons. The nucleophilic center of the nucleophile water is oxygen, which has 2 lone pair of electrons. A nucleophile attacks the nucleoelectrophilic center in the substrate and brings about a nucleophilic reaction. On the other hand, an electrophile attacks a nucleophilic center in the substrate and bring about an electrophilic reaction. This principle is illustrated in the following simple reaction, though it is not an organic reaction. Ammonia donates electron to boron trifluoride and the product's form is ammonia plus BF3 minus. Here, nucleophilic center nitrogen in the nucleophile ammonia attacks the electrophilic center boron in the electrophile BF3 and gives the product. Electronic effect in organic reactions. We noted earlier that in polar organic reactions, the nucleophilic center in a nucleophile attacks the electrophilic center in the substrate, whereas the electrophilic center in an electrophile attacks the nucleophilic center in the substrate. How electrophilic or nucleophilic center generate in a neutral substrate? This happens because of displacement of valence electron within some organic molecule, which result in their polarization. The displacement of valence electron resulting in polarizations of an organic molecule is called electronic effect. The electronic effect that occurs in the ground state is permanent effect. This takes place due to influence of certain atoms or substituents or certain structural features present in the molecule. Inductive effect and resonance effects are two examples of permanent electronic effect. On the other hand, the electron's displacement effect occurring in a substrate due to approach of attacking reagent is a temporary effect. This type of electronic effect is called electromagnetic effect or polarizability effect. We consider various type of electronic effect in the following section.